Okay, now on to the homework. I hope that you checked out the notes video that precedes this one, because for those of you who are in class today, we didn't get through everything I wanted to do during the notes section of class, so I went over kind of the end of those notes and how that works. Listening to that video is going to allow you to do number 6 if you can't already do number 6. So again, I did tell some of the classes that you don't have to do number 6 because we didn't get there in class, and I'm not requiring you to watch these videos. However, if you check out the videos, you'll be able to do number 6, and I would encourage you to do that. All right, now what I'm going to do in this video is I'm going to walk through examples 4 and 5. I'm going to leave you to do 7 all by yourself because I think you'll get a great sense of accomplishment from getting it. So, number 4. This does not need to be multiplied, doesn't need to be divided. We don't need to do anything special to it other than we're going to factor it, because right now there's nothing we can do. All right, we could break this into a bunch of different fractions, but we're not going to do that. We're just going to rewrite this. Our numerator can be factored. If this whole thing is an expression, what do both of these terms share? Well, this term has 2 x's. This term has 1 x. So I'm going to take one of those x's out of the expression, and I'm going to be left with x plus 2 inside the parentheses. All right, that's factoring. Now this one is factoring, but we're not going to be using the method that we learned yesterday. We're just going to use regular old double bubble. This is a quadratic that we can factor using double bubble. So when we do that, we have to figure out what 2 numbers add to 5 and multiply to 6. And those numbers are 3 and 2. And if you FOIL rather, you do first, outside, inside, last, you will get x squared plus 5x plus 6. All right, so now that we're at this point, we can do some canceling. X plus 2 divided by x plus 2 equals 1. So we don't need to write that anymore. It just equals 1. So we helped simplify, and we're left with x over x plus 3. That is as simple as we can make it. Now on to example number 5. Now number 5 is not like number 4 because we do have multiplication taking place. So we have to realize that that's just our numerators and then our denominators when we multiply them by each other. So when we multiply our 2 numerators, we'll get x squared plus 9x minus 22 times 1, but anything times 1 is just itself. And if we multiply our denominators, we'll get x squared minus 121 times x minus 2. Now we have to factor as much of this as we possibly can. We know that we can probably factor this numerator. It's a quadratic. If it doesn't double bubble, then we're probably going to use the quadratic formula. This is not going to factor because it's a linear factor in its most basic or simple form. This is a quadratic that probably factors nicely. So let's factor all of our quadratics. We're looking for things that add to 9 and multiply to negative 22. So those 2 numbers are 11 and negative 2. Then we're looking for numbers that add to 0, because we're missing a b term, and multiply to negative 21. This is a difference of perfect squares, so we can double bubble this. This is just x plus 11 times x minus 11, and we still have x minus 2. That's still in the denominator. At this point, we're finding things that are equal to 1. X plus 11 divided by x plus 11 is equal to 1. X minus 2 divided by x minus 2 is equal to 1. After we do that, we're just left with 1 in our numerator over x minus 11. And that's that. These aren't that crazy. You might just feel a little overwhelmed by it because we didn't get to everything we wanted to during the lesson. With a shortened class like that, we got a little bit held up, and it would have been great to get to all this in class. But I think that you're going to be able to do it at home. Now with number 7, or the last question anyway, it's not labeled number 7. This is a cube that has these dimensions. What's the volume of the cube? It's a lot like the one at the end of the notes, but I would encourage you to draw a cube and label your dimensions. Here is your length, here is your width, and here is your depth, or if you want to use length, width, and height, then here's your height, here's your width, and here's your length, whatever. But remember that the volume of a cube is equal to length times width times height. You have those dimensions, multiply them. You know how to do it. All right, guys, good luck on this. I'll see y'all tomorrow.